A joint distribution is a little similar to a relative frequency table in the sense that it's a table of percentages. As an example, this is a joint distribution. The reason we call this kind of table a joint distribution is because it's comparing two different distributions. So we have a distribution for hours spent exercising and a distribution for weight loss, and we are sort of cross-referencing or comparing those two distributions. So we'll come back to this table in a second, but let's look at just hours exercising and just weight lost. This particular joint distribution is a data table for a study that we've done with 100 participants, where the participants did some amount of exercise on average each week, and then over the course of the study, lost a certain amount of weight. So let's look first at just weight lost. So ignoring this table up here for a second, and in fact, let's hide it. Let's look at just weight lost. So we could have, from our study, just looked at the distribution of the weight lost by our participants. So we could have seen how many participants lost between 0 and 2 pounds, between 2 and 4 pounds, between 4 and 6 pounds, and 6 or more pounds. And let's recognize that this kind of looks like a relative frequency table, specifically a row relative frequency, because we have percentages in the body here, which across the row sum to 100%. Because we have 100 participants in our study, we know that this is in fact 18 actual participants who lost between 0 and 2 pounds, 31 actual participants who lost between 2 and 4 pounds, etc. So we could have just gathered data from our study and set up a distribution for weight lost. That would have been somewhat interesting, but it wouldn't have been the full picture. Similarly, we could have looked at a distribution just for hours spent exercising. So again, this is the same data, the same 100 participants in the same study, and we could have just looked at the distribution of the hours spent exercising. So we could see that of our 100 participants, 9%, or 9 of them, spent on average 0 to 3 hours exercising each week. 19% of the participants spent between 3 and 6 hours exercising each week on average, 32% between 6 and 9 hours, etc. And realize that this is a column relative frequency because we have these percentages here in the body of the table, and then at the bottom we see that they sum to 100%. The column total is 100%, so this is a column relative frequency. And while it's great that we have information here about hours spent exercising, we still don't get the full detail of all of the data that we collected in the study. Only when we look at the joint distribution, where we actually compare hours spent exercising to weight lost, do we really see the full detail of the data that we gathered. And this is actually a much more valuable table, and it should make sense to us why it is. It's more valuable because it lets us see a correlation between hours spent exercising and weight lost. Once we have the joint distribution, we can answer questions like, did participants lose more weight if they spent more time exercising? Or did participants lose less weight if they spent less time exercising? When we just looked at the distribution of weight lost, we had this total row here at the bottom, and we saw that most of our participants lost between 2 and 4 pounds or between 4 and 6 pounds. These were the largest groups. And when we just looked at hours spent exercising, we had the total column over here on the right, and we can see that the bulk of our data fell in this range here. Most of our participants spent between 6 and 9 hours exercising or 9 and 12 hours exercising. So on average, 6 to 12 hours per week is where the bulk of our participants fell. And we can see that in the detail of the data. So the largest group of participants spent between 6 and 9 hours exercising and lost between 2 and 4 pounds. That was the most common occurrence because this 17% value is larger than any other percentage in our table. The next largest group was this group, which spent between 9 and 12 hours exercising and lost between 4 and 6 pounds. So they exercised a little bit more, and they lost a little bit more weight than this 6 to 9 hour group who lost 2 to 4 pounds. We can see how helpful it is to be able to compare the amount of exercise against weight loss. And again, that's why it's called a joint distribution, because we are joining together two distributions. We're comparing the distribution of weight lost against the distribution of hours spent exercising. Now, there's a couple other things that we can get from this table, which are marginal and conditional distributions. So a marginal distribution, just think of as either the total row or the total column. So these totals here. The marginal distribution is in the margin. It's on the edge. That's a way to remember it. It's in the margin or on the edge. And so it's the total areas here. So if we want to look at marginal distribution for weight lost, that would just be this whole area right here. This sums up each column. So we can see that 18% of our participants lost between 0 and 2 pounds, 31% between 2 and 4 pounds, etc. So this gives us the full distribution for weight lost. It's the marginal distribution for weight lost. And of course, the marginal distribution for weight loss basically ignores the distribution for hours spent exercising. It eliminates all of that detail. In the same way, the marginal distribution for hours spent exercising is this over here. It's the total column, because this 9%, 19%, 32%, this area here gives us the distribution for hours spent exercising by totaling up each row. So we can say 9% of the participants spent between 0 and 3 hours exercising, 19% between 3 and 6 hours exercising, and on down the column. This distribution completely ignores the breakup by weight lost. It only gives us the totals for hours spent exercising. So those are our marginal distributions. And that's what we had before when we looked specifically at those total tables. This total table was the marginal distribution for weight lost. And notice that it doesn't give us any information at all about hours spent exercising. This table was the marginal distribution for hours spent exercising. And notice that it doesn't give us any information about the amount of weight lost by the participants. So those are our marginal distributions. The other thing that we can get from our table is what's called a conditional distribution. And in the same way that the marginal distributions were these total row and column, the conditional distributions are going to come from the data in the interior or in the body of the table. For example, this here would be a conditional distribution. It's called a conditional distribution because it's a distribution that is conditioned upon something or that depends on a particular condition. So what I've highlighted here is a conditional distribution of weight lost for the participants who spent between 6 and 9 hours exercising. So this distribution is specifically for one exact condition. This distribution is conditional upon 6 to 9 hours spent exercising. So in the same way that this is the conditional distribution for weight loss for 6 to 9 hours exercising, this is the conditional distribution for hours spent exercising based on 4 to 6 pounds of weight loss. So this column here is the distribution that shows us, assuming that we are looking at the participants who lost between 4 and 6 pounds, how much time did they spend exercising? So we're really just zooming in and examining in detail that group in our study who lost between 4 and 6 pounds, and then examining the different hours that they spent exercising. In the same way that here, we zoomed in on the group that spent between 6 and 9 hours exercising, just looked at those folks, and then looked at the weight lost for that specific group only. So this is the conditional distribution for exercise based on 4 to 6 pounds of weight loss. So just remember that we call this kind of a table a joint distribution because we are joining together two distributions and comparing them against each other. Remember that marginal distributions come from the totals, either the total row or the total column. They're called marginal distributions because it's the area in the margin or on the edge, and it just shows us the distribution for one of the variables only. So if we look at the marginal distribution across the row, we only get information about weight lost, which we see in this table. If we look at the marginal distribution down the column on the right-hand side, we only get the totals for hours spent exercising. We lose all the detail about weight loss. Conditional distributions come from either rows or columns in the interior of the table, and they're called conditional distributions because they are based on a specific condition. This is the distribution for weight loss based on the specific condition that we're looking at, just those folks who spent between 6 and 9 hours exercising. This is the conditional distribution for hours spent exercising based on the specific condition that we're just looking at those folks who lost between 4 and 6 pounds.